All right, guys, so we are on Journal 3. Let's start out with our bell work here. So for this bell work, you might have seen this question before. I'm asking what is the power for this x? Or in other words, what is the exponent for this x? So this x here, notice how it doesn't have an exponent here? That means that by default, the power is 1, right? X to the first power. Whenever there's not a power or an exponent there, it's always going to be 1. That's because anything to the first power is itself. 3 to the first power is just 3. 4 to the first power is just 4. X to the first power is going to be x. Now, the reason why I bring up this particular equation today, or x to the first power, is because that's the first function we are going to start with in Algebra 2. This function here, we are going to graph on our coordinate system. Now, if you were in class, I actually taught you how to graph it on the graphing calculators. So if you don't know how to do that and you weren't in class, let me know and I can quickly show you how to do that. So feel free to come in my office hours or after I get done with the notes during class. Feel free to ask me how to do that on our graphing calculator and I can definitely show you. So when we're graphing y equals x, you get this to appear on the graphing calculator. It kind of looks like a diagonal that goes through this point here, 0, 0, which is also called the origin. And it looks like a diagonal line, right? Or particularly, it looks like a line. We call this line a linear function. So a linear function is representing x to the first power. Now, because this goes through the origin and I'm showing you this type of function, the linear function, I'm not showing you just any linear function. I am actually showing you what we call the parent. You write that down. The parent function for linear functions. So parent functions are, or actually since that's not plural, parent function is the simplest form for a type of function. Okay? So in this case here, this is going to be the simplest form. Notice how it hits, and generally the parent function will go through the origin in one of the points. Now, let me just show you something that comes from the parent function. Like you've seen equations such as, and you don't have to write this down, but like y equals 3x plus 1. Notice how the exponent for x is still 1. So this function is kind of like the offspring of the linear function. So this one's the parent, this one is its offspring, because notice how we've added numbers here. And what this causes the graph to do, or the line to do, is it shifts. When you add plus 1 to it, it's going to shift up and other things might happen. So other equations that also have x to the first power, but different numbers added to it, is what we call its transformation of the parent function. So this is the parent function, nothing fancy, your basic level of a type of function, whereas these are, you know, other, they're derived from the linear function, but they have some extra shifting that has been added onto the function. Okay, so like I said, we are learning linear functions from for this chapter here. So let's move on to our next slide. So we're going to start off by learning how to find the slope or the rate of change. Now, most of you probably have learned this in your Algebra 1 class, right? And so remember that slope is always your rise over run, where rise would be the y part of the coordinate. So if I were to like draw a coordinate system here, your rise are typically referring to your y-axis, like how far does it go up or down, whereas your run is referring to the x-axis, how far you're moving left and right. And then you might have also have learned the slope formula a long time ago where you're given 2 points. So let's say these are our 2 points. Then our formula for the slope needs to be where the rise is in the top. So the rise, like I said, was referring to the y values. So on the top here needs to be y2 minus y1. Whereas the bottom here is going to be my run, and it's going to be referring to the x because it's talking about how far am I moving left to right. So x2 minus x1. Notice how the top here, when you're subtracting the y's, you're finding the change in y. Whereas the bottom here, you're subtracting the x's, so you're finding the change in x's. Well, when you divide the change of y over the change of x's, you get something called the the rate of change or the slope. Okay, definitely need to know these two, formulas. Well, I guess this is the only formula. This is just what the slope represents. So let's talk about different types of slope you might encounter. So if you have a positive slope, a positive value of a slope, you will notice that the graph points up as it moves to the right. So it points up like this. This is what we also call an increasing linear function. Anytime you have a negative slope like this, it's going to be moving down as you move towards the right. This is called decreasing, a decreasing function, linear function. Then you have situations where the slope is 0. So if the slope is 0, that means there's no increase or decrease in the slope for the line. So that means there's no elevation of the line, which means that you have this flat line. In other words, a horizontal line is what we refer to it. Last but not least, we have something called undefined, okay? So undefined happens when you are dividing by 0. So the thing is, in mathematics, you cannot divide by 0. Or in other words, the denominator of a fraction can never be 0. If you notice a denominator, or when you subtract the x's, that gives you 0, this is what leads to being undefined. An undefined graph looks like a vertical line. And those are your 4 types of graph. You can either have a positive, negative, a 0 for a slope, or undefined, and those are the corresponding types. They are referred to on the graph. All right, let's do some practice problems here. Okay, so on this graph, I'm going to make up some problems here that we're going to do. So we're going to determine the slope of each line. Let's see. I'll make up some numbers. That might work out nicely. So this is -3 and 2, and this is 2 and 5. And then maybe I'll put one that's like right here. Maybe like right here. And then one right here. Okay, so if I wanted to find the slope, right, I need to figure out, I can either use these 2 points and use the slope formula. I could do that. But here's the thing, I have a graph. I can always just count from one point to another how much it's rising and how much is the run. So like if I take a look at maybe this point here, right, and I go to that point, I am going up, looks by 3. So I'm going up by 3. And then over 1, 2, 3, 4, 5. So if I went up 3, I'm adding 3. If I went over to the right 5, I am adding 5. So this is really, so it's rise, so 3 over 5. And notice how this slope here 3 over 5 is a positive number. So a positive number means that this slope is increasing. And you can also see that it's increasing by just, seeing that it is pointing that way as it moves to the right. When I look at this one here, notice how here's your 2 points. Again, you can use your graph to figure out how much it's moving up and down and how much it's moving left to right. So it looks like from this point to the other one, it moved down by 1, 2, 3, 4, 4 units. So that's going to be a negative 4 because it's moving down. Then, if I were to go to, it looks like to the right here, 1, 2, 3, 4, 5, 6, 7, 8. Looks like I am adding by 8. So my slope here is, so the rise, which is negative 4, make sure you use that negative, over 8, positive 8, which is the run. And so remember not to keep your answer like this because this is a fraction and that fraction's reducible, right? 4 and 8, what divides into 4 and 8? 4, right? 4 divides into 4 one time, so negative 1. 4 divides into 8 2 times, so 2 here. And so this here is my slope. And also it's a negative, so it's decreasing. And you can see from the graph here that as it's moving more to the right, it is going down. So definitely it's decreasing. All right, let's do some more problems, but without those graphs there, just the coordinate points. Okay, so I'm giving you a pair of points, and you need to determine the slope, okay? So we talked about the slope formula a moment ago. When you have 2 points, it was this formula here, the y2 minus y1 over x2 minus x1. So if you need that, feel free to look back at that formula here. I just wrote it here so that way you can see which one I was referring to. So these are my 2 points. Let's say that this one's my first point, so x1, y1, and let's call this x2 and y2. So if I were to use the formula here, I would do, keep readjusting this. So I would have m equals my y, subtract it with itself. So my y's are 0 and 5. So 0 minus 5 over my x's, x2 minus x1, so it would have to be this one, 8 minus 3. If you subtract, that's negative 5 over 5, and then if you divide negative 5 with 5, you get negative 1. So you can leave your answer like this, but let me just go ahead and say there's another way you could solve this problem. So whichever pair you decide to make your first one that you decide to subtract with, doesn't matter. What matters is that the x and y's match when, vertically. Like you see how this 0 here is your y? The corresponding x to that is 8 and it's right underneath it. Whereas 5, the corresponding x here is the 3. Notice they come from the same pair. So that's really important to be aware of. Because if you were to flip-flop them, like do 5 minus 5 and then the bottom you flipped as 3 minus 8, you might notice that your answer doesn't come out the same. So you could have also done this as, instead of 0 minus 5, use this one as your first, so I guess as your second function. So if you were to take this guy and do 5 minus 0 instead, over 3 minus 8, so you'd have 5 over negative 5, which is also negative 1. It's the same as this one. And so now you could say that these 2 pairs are, well, since the slope is negative, I guess it's decreasing, right? Decreasing. Okay, next one here, I'm going to also solve it out. So I'm going to set up my slope here. I'm going to take my y value, so 1 minus 1, over 8 minus 3. So that's 0 over 5. Whenever you divide something by, whenever you take 0 and divide it by some number, it's always going to be 0. Anytime the numerator has a 0, you're going to get 0. So anytime the numerator is 0, whatever you're dividing by, if you're dividing by some number, positive or negative, you should get 0. So if the slope here is 0, that means we have a horizontal line. And then this one here, the last one, I'm going to set up the slope. So I'm going to do my y's first. 7 minus 1 over 5 minus 5. And so the bottom here is a 0, and 7 minus 1 gives me 6. Oh no, the bottom 0. Whenever you're dividing by 0 on the bottom, that means that you have something that's called undefined. And that's going to be a vertical line. Okay, so I hope this helps you out a little bit. Feel free to practice this. We have 2 more slides just talking about linear pattern. Okay, so how we determine if something is linear, so let's talk about that. So if we have like a table where there are x and y values, and we are going to be looking at how they are increasing or decreasing, and looking for a constant rate. So in other words, as x and y are decreasing or increasing, are they following the same pattern or the same constant rate? So constant rate is another word for slope. And so this is to help us find a linear pattern. Linear equations have a constant slope or rate of change. That's just saying that linear functions have the same slope as you move through the grid or coordinate system. Okay, so we're going to take a look at one more example slide. Okay, so in this slide here, I have 2 tables, and we are given the table to determine if it represents a linear pattern. So you can see with the x's here, as you move from the highest point to the lowest point, looks like it's increasing by 1, right? Nothing too fancy. Increasing by 1. And then for the y's, you might notice that it's increasing by 2's. Oops, sorry, 2. Erase that. It might just be easier. So we're increasing by 2. Okay. So in this case, because the x and the y both are increasing by the same number, that means that the slope is going to be the same or constant. Because remember, slope, rate of change are the same, and slope is made of x's and y's. So if the x's and y's are increasing by the same rate, then the slope is going to be increasing by the same rate. So in this case, this is yes. Actually, let me grab a pen here. There we go. So yes, it's linear because the slope is constant. Okay, so now let's take a look at the second one here. You might have noticed at the bottom here, as we're moving along from 0 to negative 10, it's subtracting by 10, right? Negative 10 to negative 20, subtracting by 10, 20 to negative 30, minus 10. If I subtract another 10, it's just going to get a bigger and bigger negative. Now, if I were to look at the top, I might see something completely different. So this is adding by 2, but wait, hold up. Sorry, I should have been adding by 2. So from 6 to 7, I am adding by 1, right? And from 7 to 8, I'm adding by 1. So this tells me that I have a discrepancy here. The slope here, or the run here is adding by 2, but then it switches to adding by 1. So in this case, this is not a linear because the slope is not constant. So no, it's not linear because the slope is not constant. All right, so I hope that helps you out a little bit. Just kind of an overall of this slide here is like if you want to find something as a linear pattern, you have to make sure that the x and y's are growing or increasing or decreasing by the same amount of number. Anyhow, that's it for this journal. Check out page 2 of the packet now. You should be able to have notes over that topic. So page 1 and page 2 are now assigned in packet 1. All right, have a great day, guys.